Another problem that we might encounter on this particular section here is the limit at infinity section is one like this. We got limit as x goes to infinity, but the top has a square root in it. And so I wanted to talk a little bit about that and a couple other things too that we might encounter. Yeah, so same deal. I would divide by the largest power x in the denominator, which in this case is just x. So divide by x, divide by x. The problem is, yeah, like I said, the top has a square root in it. And so dividing the top by x, those two don't match. I can't put those two together, if you will. What I need is, I need this represented in a square root form. So how could I represent x equals square root of what? Well, since x goes to infinity, it's actually pretty easy. What would give me, as x goes to infinity, what would give me x if I square rooted it? Well, it would be square root of x squared, wouldn't it? Wouldn't the square root of x squared equal x as x goes to infinity? Because, you know, we've talked about things like this. The square root and the square basically are going to cancel one another out there. So isn't x represented as x goes to infinity, positive infinity, right? So instead of dividing this by x, I do the equivalent form of that, divide it by x squared. So instead of dividing this one by x, which technically I am, I really divide it by the x squared. So essentially here's, I'll write it this first time. So I'm dividing the top by x squared, square root of x squared. Now the bottom, same old, divide that by x, you got 3, divide that by x, you got minus 5 for x. What this allows me to do though on the top is now they're both in square root form, I can divide those together, combine those together. And so essentially what I've got here is I've got 2x squared divided by x squared. See what I'm saying? And so that would be 2. And then 1 divided by x squared, so that's plus 1 over x squared. And now that's in the square root. Okay? So, all right? So you see why I divided by x squared here instead of x? It's because it's under a square root. Well, that being said then, the same deal holds if you've got 1 over an x to a power, or a number divided by x to a power, that's still 0. So this still goes to 0. This goes to 0. And so I wind up with the limit as x goes to infinity. Actually, evaluate it. So as x goes to infinity, this goes on top, goes to 2 plus 0. And then bottom goes to 3 minus 0. So I wind up with the square root of 2. That's the limit of that as x goes to infinity. Okay? Now, there's a little bit of a twist, if you will, if I go x goes to negative infinity on this one. Previously, it didn't really matter when x goes to negative infinity or positive infinity. It always was the same thing. There's a slight little wrinkle in that x goes to negative infinity in this case. So let's do the same one, except we're going to say x goes to negative infinity. All right, so the reason this works is because, in this first case here, the reason that worked is because, yeah, if I was, so x was going to infinity, large numbers of x. That's true, right? Because large number, let's just pick 100. 100 does equal the square root of 100 squared. That's true. Now, however, x goes to negative infinity. So what does x equal the square root of in that case? All right, so x is large negative numbers. So let's go with negative 100. X is negative 100. Does negative 100 equal the square root of negative 100 squared? Is that true? That is not true. Because if I square root negative 100 squared, negative 100 is 10,000, and the square root of 10,000 is not negative 100, is it? It's positive 100. So how do I make the adjustment? Well, negative 100 doesn't equal the square root of that, it equals the negative square root of that, doesn't it? See what I'm saying? Then it works out. So, as x goes to negative infinity, x doesn't equal the square root of x squared, it equals negative the square root of x squared. Okay? So that's the little adjustment here. Yeah, I'm going to divide top and bottom by x here. But, because I'm going to negative infinity, the x is equal to the square root of x squared negative that. Okay? So what does that mean? So if I divide this top by this, here, let's write it out. So it's the square root of x squared plus 1 divided by negative of the x squared. And the bottom is divided by x, so that's 3 minus 5 over x. Okay. What does this give me when I do that? Well, it gives me the limit as x goes to negative infinity. Negative square root 2x squared divided by x squared is 2. 1 divided by x squared is 1 x squared. So only real difference between this one and this one is now I've got this negative in front of the square root. Because that's what I have to do to make this, since x goes to negative infinity. Yes? Well, that goes to 0. That goes to 0, so I've got basically the same thing, except it's negative, right? Negative square root of 2 over 3. So, anyway, just a slight little variation on something we did earlier. Okay? All right, now, just a little bit of discussion here on what are called indeterminate forms and forms that are actually can be determined. Indeterminate forms, I don't think that's actually a term used here, but kind of important that kind of have an idea anyway about what are called indeterminate forms. The ones we've been working with so far, indeterminate forms, has been infinity over infinity. Basically what I've come up with, the reason I've been doing the approach we've been talking about is we've had an indeterminate form, infinity over infinity. A good example is, if I have a limit as x goes to infinity, x squared plus x over x squared minus, or say plus 3x plus 4. Essentially what I've got here is the form is infinity over infinity. If I just plug, if I just plug in the infinity right here, I've got infinity squared plus infinity, that's infinity. And then infinity plus 4, that's infinity, okay? So you see what I'm saying? That's the form, if I just plugged in, before when we used the factoring technique, it was because, well, in that case, it was a different form. It was, we didn't mention it there either. If I've got the limit as x goes to 2, x squared minus 4 over x minus 2, that's the form. What form would that be? 4 minus 4 is 0, 0, 2 minus 2 is 0. That's the form 0 over 0. And so that's another indeterminate form, 0 over 0. See what I'm saying? So those are indeterminate. I can't tell you what this is because it's infinity over infinity right now. This form is 0 over 0. I can't, until I do something else, like on this one, divide by x squared, I can't tell you what it is, so it's indeterminate. Until here, this is factoring, I would use factoring here. I can't tell you what the answer is because it's an indeterminate form 0 over 0. You see what I'm saying? Those are indeterminate. I don't know what happens to them until I do some other stuff to them. Okay? Now there's another, so those two we've kind of talked about already. There are some other ones that we're going to, another one that we're going to mention here, another couple of them, examples of it. One of them is, another indeterminate form is infinity minus infinity. That's also indeterminate. Or you might be saying, isn't that 0? Could be. It could be 0, but it might not be either. You know, just like this, infinity divided by infinity is not 1. I mean, in some cases it is. That, but if I put a 2 there, that's going to be 1/2. So you don't know what that's going to be. And then here, like I said, that may be 0, it may be 1, it may be 1/2, it could be anything. Same thing can happen here. Infinity minus infinity, it may be 0, but it might be 1/2, or infinity, or -5. Okay, we just don't know. It could be anything. That's what we're saying. They're indeterminate in that format. So we have to do some other stuff to it. Now, just so you know, there are forms that are not indeterminate. Like if I have 1 over infinity, or some other number over infinity, what is that? That's 0. So that's not indeterminate. That's, you know, we use that fact to our advantage, right? That's 0. That's 1 over infinity. And that's always going to go to 0. So that's not indeterminate. So you see the difference I'm driving at here? If I've got 1 over infinity, that's 0. Or a number divided by it. Or another, to play off of this one, what about that? Infinity plus infinity. Well, just think through that. I've got something that's going to infinity, then I'm adding something else that's going to infinity. I know what's going to happen there. That's going to be infinity. Because you got something here and you're adding more to it, that's definitely going to be infinity. Okay? The problem here is I don't know what happens. And I'll show you why that it is indeterminate, because you just don't know. Okay. All right. For example, the limit as x goes to infinity, x cubed minus x to the 5th. Well, if I plug in the infinity, I've got infinity cubed, which is infinity, minus infinity to the 5th, which is infinity. So you see I've got this infinity minus infinity. It's indeterminate. Is it 0? I don't know. Is it infinity? I don't know. As it is, I just can't tell. So I have to do some things. In this particular case, I can do a little bit of factoring. Because another form that's not indeterminate, so that's not indeterminate. What about this? Is that indeterminate? if I've got something infinitely large times something else infinitely large, isn't that going to be infinity? So that's not indeterminate either. It's infinity. Well, that's what I'm going to use here, is the fact, well, let me factor this. It's x cubed, pull out an x cubed, and then it's 1 minus x squared. What have I got now? Well, I've got infinity, cubed is infinity, and then 1 minus infinity squared, that's infinity. But if you've got 1 minus infinity, a number minus something infinitely large, that's going to be infinity, isn't it? Or negative infinity, sorry. So what is this? That's no longer indeterminate, is it? Because now I have infinity times negative infinity. I mean, it's a little adjustment here, but so I've got a large number times a large negative number. What is that going to give me? A large negative number, isn't it? Negative infinity. Okay, so sometimes you can do a little factoring and get away from this infinity minus infinity, which is indeterminate. Because the next one I'm going to show you is not negative infinity. It can be, like I said, this can be just about anything, just like the other indeterminate forms. So here's the last one I'm going to show you. What if I had the limit as x goes to infinity, the square root of x squared plus 1 minus x? Well, as is, the form that I have, what would it be? X goes to infinity, so I have square root of infinity squared plus 1. Well, that's going to be the square root of infinity, but the square root of infinity is still infinity. So this would be infinity, and then x goes to infinity, so it would be infinity minus infinity, isn't it? Right? Indeterminate. That's indeterminate. So I have to do something. What that means is I have to do something else to figure out what it is. Okay? And so, on this one, we're going to pull out an old friend we've used before, the conjugate. Let's multiply the top and bottom by the conjugate. Remember the conjugate? Just change the sign between them. So it'll be the square root of x squared plus 1 plus x. But to make this a legal maneuver, we have to do also the same thing, multiply with the denominator. Now, of course, we understand here, square root of x squared plus 1 minus x doesn't have a denominator showing, but what is the denominator? It's 1, isn't it? Just divide by 1. Okay. So are you with me so far? Now, when I multiply these conjugates together, remember what happens. You got the limit as x goes to infinity. So this times this gives me the square roots cancel, so you get x squared plus 1. The middle terms drop out, because you'll have that plus that, and then that times that gives you minus the same thing. So those cancel out. And then the other piece is you have it minus x times positive x, be a minus x squared. And the bottom, since it's 1 times that, is just square root of x squared plus 1 plus x. So far so good? Well, nicely, the x squareds cancel on the top. And we're left with 1 over the square root of x squared plus 1 plus x. Now there's a couple ways we could go here, but let me show you this way, because I don't think it would always work one of the other ways I'm thinking. Now, since I've got this set up, I can use my other technique, which is divide by the largest power of x there is on the denominator. If you think about it, the largest power of x here I have is x to the first power because, yeah, I've got x squared, but it's square rooted. That's still x, you see. So I'm going to divide top and bottom here by x. Okay? So the top I'll have 1 over x divided by, I'll talk about this square root here in a second, and then this part will be plus 1. Okay? Now, when I divide this by x, and again, this is just kind of reinforce what we did before, since it's a square root, what do I have to divide it by? Instead of x, divide by the, erased it, but divided by the alternative form of x, which would be the square root of x squared. Yes? So this one is divided by x square root of x squared. So what is that going to give me? X squared divided by x squared, so that'd be 1, and then plus 1 divided by x squared. Except we might not have to do that here, but I wanted to show you another one with that same technique, because it works as well. With me there? So what does that give me? Well, as x goes to infinity, that goes to 0, right? And that goes to the square root of 1 plus 0, right? Plus 1, that's 0 over the square root of 1 plus 1, that's 0 over 2, that's 0. So just to recap here, this infinity minus infinity did turn out to be 0. The previous one, what was it? Limit as x goes to infinity, x cubed minus x to the fifth. Through some calculations here, a little bit of work, that turned out to be negative infinity. So that's what I'm saying. Infinity minus infinity is indeterminate. If you've got infinity minus infinity, you can't say what it is because it may be 0, but it may be negative infinity, or it may be positive infinity, or it may be 1/2. Okay, you just don't know. So you have to do some stuff. Is that right?